All right, so this is a another video on solving systems with three equations. So we're going to do another example. I think it's good to see more examples, and different possible solutions to these types of problems. And so, if you haven't watched the other videos, make sure you watch those before you get to this. But let's go ahead and get started. So we don't waste too much time just talking. Okay, and so here we go again. Same idea. We got three equations, three variables, and we need to solve this system. And so when we need to solve, we need to find x, y, and z. The x, y, and z that makes this. And so basically, again, let's start off by numbering our equations so we can talk about them. So this is equation number 1, number 2, and number 3. Okay, and so this is, if you kind of look at this problem, it's somewhat interesting. You've got a if you look at it, you see this has an x, a y, and a z, and this has an x and a y, or an x and a z, and this is an x, and a y, and a z. And so if you look at this one, and they'll do this sometimes, this only has two variables. And, you might call it different. That's not good. That's actually a good thing, because if you remember that the first step when solving these is you try and eliminate one of the variables. And so in this case, we've already eliminated one of the variables. We eliminated y, so we kind of saved time in that sense. So that's a good thing. Okay, we don't have to do anything to equation number 2. We already have eliminated one of the variables. So what we're going to do is we're going to use equations 1 and 3 and eliminate the same variable that's non-existent here. So there's no y here. So using equations 1 and 3, I'm going to eliminate the y variable, because then I'll have two equations, which is two variables. I'll have equation number 2, right, because it doesn't have a y, and then I'll have the equation that I get from adding equations 1 and 3 also won't have a y. So let's go ahead and do that. And so before I rewrite this equation, let's think about how am I going to eliminate the y. So this is a negative 3y, and this is a negative y. And so I want to make those opposite. So if this is negative 3y, I want to make this a positive 3y. So what number times negative 1 will get me a positive 3, right? I want the opposite. So that would be a negative 3. So what I'm going to do is I'm going to multiply this whole equation by negative 3. And then what I'm going to do is I'm going to rewrite it right here. Okay, and let's use a different color. So negative 3 times x is negative 3x. Negative 3 times negative y is positive 3y. Negative 3 times positive 2z is negative 6z. And negative 3 times 4 is negative 12. And then I'm going to just basically take this equation and write it right underneath there. And so I'll have 2x minus 3y plus 5z equals, oh, I'm not room on my board here, equals 4. Okay, and let's take those two equations, add them together, and eliminate the y's, right? Those are going to go away. So we'll have negative 3x plus 2x gives me negative x. I have negative 6z plus 5z, and I will get negative z. And I have negative 12 plus 4, and I'll get negative 8. Okay, and so now I have two equations with two variables, right? I have equation number 2, and then I have this green equation. So let's combine those. Let's write those right underneath each other. So I have x plus z equals 6. And then I have negative x minus z equals negative 8. Okay? Okay, so we got two equations with two variables. We got x and z left over. So what we're going to do now is basically, see if we can eliminate one of the x's or the z's. Or maybe in this case, we both. Let's see what happens. Okay, so let's get a different color here. Oops. Okay, let's add these together. And what you're going to get here is you got x plus negative x, right? And we're going to get 0. Right? That goes away. I guess I don't need to write the 0. You have negative z plus a positive z. That's also going to go away. So on the left side, all you have left is a 0. And on the right side, okay, on the right side over here, we have 6 plus negative 8, which gives me negative 2. And so, wow, what happened there? Both of the variables went away. And so That's actually a good thing if you think about it as a time thing. This actually shorten the problem. This makes the problem take less time, right? So we get down to this fact here: 0 is equal to -2. Is that true? I mean, obviously that's not true. 0 is not equal to -2. 0 is equal to 0. So what does that mean? Okay, and just like when we had two variables, if you ever got something that was not equal to each other, that meant there was no solution. Okay, there's no solution to this system of three equations. Okay, so whenever you get something that says 0 is equal to -2, or 5 is equal to 6, or some equality that is not true, that means it's a no solution, and that's what you would write for your answer, would be no solution. Okay, and so that's the instance if you have no solution.